Hi, everyone, and welcome back to Science Unveiled, the show where we delve into the latest breakthroughs and ideas shaping our world. I'm Emma.
And I'm Alex. Today we're exploring a fascinating perspective article titled Patterns Lead the Way to Far from Equilibrium Materials by Pamela Knoll, Bin Ouyang, and Oliver Steinbach.
This article is a deep dive into how patterns, both obvious and hidden, are fundamental to understanding complex systems in physical chemistry, especially as we stand on the brink of an AI-driven revolution.
Exactly. The authors suggest that patterns are not just aesthetic or incidental. They're central to predicting future events and understanding the universe's fabric, from the periodic table to crystallography and even the genetic code.
Let's start by discussing the role of patterns in scientific discovery. The human brain is wired to recognize patterns, which has been crucial for our survival and evolution. In science, recognizing patterns allows us to formulate hypotheses and develop theories.
Right? The article emphasizes that while humans are good at spotting patterns, there are limitations, especially when dealing with high-dimensional data or complex systems where patterns aren't immediately apparent.
And that's where AI and machine learning come into play. Advanced algorithms can process vast amounts of data and identify patterns that might elude human intuition. For example, AI models like AlphaFold have predicted the structures of thousands of proteins with remarkable accuracy.
That's a game changer for fields like drug discovery and biotechnology. But the authors also caution that AI isn't a silver bullet. It's a tool that needs to be guided and interpreted within the broader context of physical sciences.
One of the exciting areas the article explores is high-entropy materials. These are materials composed of five or more elements in roughly equal proportions, leading to a high degree of disorder or entropy in their atomic arrangements.
Yes, and despite, or perhaps because of, their disorder, these materials exhibit unique and valuable properties like enhanced strength and ductility. The lack of a regular atomic pattern actually contributes to these beneficial characteristics.
It's a bit counterintuitive, isn't it? Traditionally, we think of well-ordered crystal structures as being essential for desirable material properties. But high-entropy materials challenge that notion.
Absolutely. And AI can help us navigate the enormous compositional space of these materials. By identifying patterns in how different elements interact, machine learning models can predict new high-entropy materials with tailored properties.
The article also delves into far from equilibrium materials, which are systems that are not in thermodynamic equilibrium and often exhibit dynamic behaviors like self-organization.
These materials are fascinating because they can form complex, lifelike structures without any biological components. Think of chemical gardens or oscillating reactions like the Belousov-Jabotinsky reaction.
These systems show that under the right conditions, simple chemical reactions can lead to complex and ordered structures. It's a reminder of how life's building blocks might have formed from non-living matter.
And speaking of the origins of life, the authors discuss how studying these far from equilibrium systems could provide insights into how life emerged on Earth and possibly elsewhere.
That's a profound implication. If we can understand the patterns and processes that lead to self-organization in chemical systems, we might get closer to answering one of humanity's biggest questions. How did life begin?
The intersection of AI, pattern recognition, and physical chemistry opens up new horizons. But as the authors point out, it's crucial that we use these tools responsibly and remain critical of the results.
Indeed, AI models can identify patterns, but they can also be prone to biases or misinterpretations if not properly guided. The human element, our intuition, skepticism, and understanding of physical laws, is still essential.
In conclusion, the article is a call to action for physical chemists and scientists in related fields. By embracing AI and focusing on patterns, we can unlock new materials and technologies that were previously unimaginable.
It's an exciting time to be in science. The challenges are significant, but so are the opportunities. Well, that's all we have time for today.
Thanks for joining us on this journey through the frontiers of physical chemistry. If you're interested in reading the full article, we'll have a link in the show notes.
Don't forget to subscribe to Science Unveiled for more deep dives into cutting-edge research. Until next time, I'm Emma.
And I'm Alex. Stay curious.